Good morning, everybody. My name is Eza Budi Perkasa, and I'm here from ISB at Maluhur, and will present my paper titled Coordinate Network Modeling for Lemma Recognition in Baka Dialect of Malay. So the introduction is, computers now cannot be separate from life. Computers are able to make work easier because it has been equipped with intelligence. For example, in the study is that for data classifying. The main problem in this paper is Baka dialect of Malay lemmas is numerous, so many, and adding new lemma is not as easy as thought because it must maintain the characteristic of Baka culture. Tracing all lemma is impractical work because of so many lemmas. The statistic is there are 2060 unique lemmas registered. My literature review, there are some researchers that has do research about the coordinate network. They are Zethu et al., Siswe et al., A. Mohammed, Wiley et al., F. Semer and M.R. Abu Bakar, and T. Kruliki. Different method, and the difference of mine and them theirs is I use the coordinate network from the string recognition. For model, I design step by step this data normalization phase first, and then formation of training data input vector, then weight initialization, and finally training parameter determination. For data normalization, I have three steps. That is, first, raw data. I prepare raw data. For example, here, Aitatong and Swahilian. And then removal of special character. Here, I will remove the space. Then finally, I will change the capitalization to make the writings uniform. The next step is formation of training data input vector. For example, here I would like to formation the Aitatong. I will split it into several blocks of 2 characters each. Yeah, so 2 characters each of block, and then the block is given a numeric value. The numeric value is got from this table named substring frequency table. So this number are then divided with sum of this number, so that we can get a decimal value. This here is the training data. So I have 13 training data from the lemmas in the dictionary. With initialization, so as we know, total value on the SFT or string frequency table is 6,946. Thus, the initial weight of 4 non-optimized on optimization table are 0.00142 and 0.00189 respectively. Optimized, what it means, there are some columns and or rows that has all zero values. It can be removed. That become unoptimized. This is not optimized person. Because there are 2 possible outputs and maximum of 7 substring blocks, and as can be seen here. So those weights become elements of a 2 by 7 matrix. The training parameters are initial learning value is between 0.1 and 1 by a chain of 0.1 per experiment. So there are 10 experiments total. The learning rate is modified by a half every increase in epoch. Maximum number of epochs is I'll simply take the square root of 2060, which is the number of lemmas all, which is approximately equal to 45, 45 epochs. Here's the result. So the result, as we can see here, the result is variable depending on optimization use, and the result is not having a linear relationship between the learning rate and then numbers of lemmas recognition, either optimize it or not. So the conclusion is, depending on optimization use, the number of recognition lemma is variable, as can be seen in this graph. There are no relationship between learning rate and number of recognition lemmas. In future work, next researchers can do as following. First, uh, they can uh, they can change parameters of core network use, so the result can be compared. And second, they can add or change training data. They can involve the non-Baka dialect of Malay, such as English or whatever language it is. And the third, show the translation of the recursion lemma. So the newcomer can learn the word or the lemma. So this is not just the recognition, but also showing the definition. What is the lemma means? Okay, that is my presentation. Sorry for my bad English. See you later, and goodbye.